Okay, let's turn our attention towards our Unit 5, Day 3, 4 corners. It is called 4 corners because we're going to talk about the 4 different representations of a function. The first one in the top left-hand corner is the verbal description. It deals with words. It can be a story. Please write down the story here as we begin. It says, the zookeeper measures the height of a giraffe once a month. The giraffe was born at a height of 110 inches. The giraffe grows 4 inches per month. Okay, well, here we have a situation where the giraffe's height is going to depend on the number of months. So what's being depended upon, or what has to happen first here, is the number of months. Let's call that M. What's depending on that, or what the months are affecting, is the giraffe's height. Let's call that H. And we're measuring that height in inches. So I'll put that down as well. Okay. Since we now know the independent-dependent relationship, we can go to our top right-hand corner and we can write down our function notation. Okay. If H depends upon M, then H is a function of M. And the way we can write that is we can say that H is a function of M. Okay? Well, what we also want to write down is an actual function or an equation that describes this situation exactly. So it's not just which one depends upon each other, but we also want to take into effect the constants. Okay? So here is the basic template, if you guys would copy this down for me. The basic template of your equations is going to be the dependent variable is going to equal the rate of change. Write this down, please. Times the independent variable plus a starting point. Now, as we look back at the verbal description, we can begin to plug in the values that we know here. First, the dependent variable, the height, is H. The rate of change is how much the giraffe is growing each month. That's how it's changing. Well, that value is 4. And it's 4 inches per month. There's our independent variable. The starting point is where the giraffe started. It's how big it was when it was born. Well, it was at a height of 110 inches. This H equals 4M plus 10 is the equation we're going to use to fill in the other 2 corners of the worksheet. Let's keep going. Bottom left-hand corner, table. As you look at your table, the independent variable is always going to be over here on the left. Okay, so let's write independent here, which means that the dependent is always going to be over here. All right, well, the independent value is talking about months, and we call that M. The dependent value is the inches, and we call that H. Now, what we're going to do is we're going to take our 4M plus 110, and we're going to start plugging in these values of M, the 0, the 1, the 2, the 3, and so forth. And we're going to show the process. We're going to show us plugging in or evaluating that equation before we get our final answer. Okay, so when M equals 0, we'll have H equals 4 times 0 plus 110. That means that H is going to be 110. We're going to keep on working our way down the table, plugging in the values over here on the left for M. And, of course, we're going to get slightly different answers for H. Let's keep going. Notice as you go from 3 to 10 that we are skipping some values. That's okay. Double check my math here. That's 60, 170. That's 120, that's 230. Okay. What we want to do is, now that we've seen the process and we've developed values for H, we now have ordered pairs. We have M values, and we also have some H values. Each one of these M and H values pair to become a location on the graph. So we're going to plot these 1, 2, 3, 4, 5, 6, 7 order pairs on the graph. As we go over and look at the right side, notice that the graph is, well, it's naked, right? It's not labeled or scaled. So we need to take care of that. First of all, we remember from day one where to put our independent and dependent variables. The H is the dependent, so let's go ahead and throw that guy over there. The M is the number of months, it's the independent, so let's throw this guy down here. And then what I want to do is I also want to think about how I should scale my graph. In other words, how much I want to go up in each one of these little bitty rows in order to fit all of my data. Okay. Well, notice that all of our values for M went from 0 to 30. Okay, well, I'm always going to have you guys start at 0 here on the origin. So what we got to figure out is how much do we want to make each one of these little marks go up by so that we can fit 30 in there. Okay, well, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. There are 10 marks. Well, what do we need to go up by to eventually reach 30? Hopefully you said 3. That would be an excellent scale. And let's scale our graph by that amount. If we do it correctly, we should end up being able to fit all of our M values in there. Let's think about the H values. The H values go from 110 up to 230. Now I'm going to have you guys start at 0. I'm always going to have you guys start at the origin. And what we got to figure out is how are we going to scale our graph in order to reach 230. Well, let's see here. We have 1, 2, 3, 4, 5, 6, 7, 8 of those little marks. So what you should do is you should take that 230, divide it by 8, and what you end up getting is 28.75. Now, I don't want to go up by 28.75 on each one of these marks because that'll make it very difficult to graph. What I want to do is I want to pick a whole number that's around that number that's a little bit bigger to ensure that I'll fit all those values. So the nearest one around there is 30. So 30 would definitely work. So let's scale by 30. A question's going to be, do you absolutely have to scale your graph the same exact way that I do? No, I want you guys to pick reasonable values. And I want to make sure that you can fit all the order pairs from the table on your graph. All right, let's plot these guys. Let's see what we get. 0, 1, 10, 1, 1, 14, 2, 1, 18, 3, 1, 22. Let's see. The next one was 10, 1, 50. Okay. And then 15, 170. And then 30, 230. Okay. These look like, assuming that I could graph well, these look like these kind of line up. So then our next question would be, should we connect these dots? Or should we leave them dots? In other words, is this graph continuous or discrete? Okay, well, think back to the way that the zookeeper is actually taking his data. Yes, he's using time as one of his variables, which usually is a continuous variable, but he's taking his measurements once a month, which means he's not going to know the height of the giraffe in between those months. So we should not connect these dots. This graph should be discrete. Okay, let's answer the questions on the bottom. Finish strong here. Number 1 we just answered. It says, does this data create a discrete or continuous situation? It does create a discrete situation. Justify your choice. A good way to say that is the zookeeper takes a measurement once a month. There's not going to be any fractions or decimals or values in between. Okay? What values are staying constant in this story? Well, these constant values are the values that we found up at the top right-hand corner. It's these values for the rate of change and the starting point, the 4 and the 110. Throughout this entire story, the 4 and the 110, the rate of change and the starting point are not going to change. So the rate of change equals 4, and the starting point equals 110. Okay? Why is it not possible to have a negative number in the domain? Okay, first of all, you got to remember what domain means. It's talking about all of your x values. So why aren't we talking about negative values for m here? Okay, well, if we're talking about negative values for m, we're talking about before the giraffe was born. So it doesn't make any sense. So that's what we need to write. We can say that that would be before, let's try that again. That would be before the giraffe was born. Okay. Leave the backside blank. We're going to finish that when we get back to class. I wanted to give a shout out to my 5th period because they are my best and my most favorite period on B days from 9:20 to 10:55. All right. Have a good one. I'll see you guys in class. Take care.